Hi and welcome. If you've been watching my channel for a while, you might have seen a video quite a while back where a very generous gift from Lance Baltzy. He sent me these precision ground FlatStones, which I use all the time, especially on the surface grinder. They're pretty fantastic. And the whole theory behind these guys is that they're ground so flat that when you put them on something that is also equally flat, the points of contact will be so many that there won't be enough force to actually remove material. So the only thing that will get removed is little high points that stick up. And you can tell precision ground FlatStones, this is the coarse side, this is the fine side. You can hear that. You hear how they slide past each other? You can self-level after you get them. There's the fine side. And so I use these constantly on the surface grinder. They are absolutely fantastic. It's a wonderful gift from Lance. But these are kind of large, and I find that they kind of run into things. So I was hoping to make some smaller ones. I thought I'd try my hand at it. So I picked up these Norton stones, and the small ones are the Sportsman stones, and the bigger ones are some other ones. They were on McMaster Carr. If you want to see the Norton model number, there you go. Hopefully you can read that. Here's the other Norton model number. And interestingly enough, I mean, I've never tried to grind, I've never ground anything like this before. We're using the diamond wheel. Here are the brand new ones. Here's what they sound like right out of the gate. You can see they're nowhere near as precisely flat as the other ones. Oh, look, they're not even equally thick. So that's the one side. And so if you try these on a piece of metal, you'll end up scratching it up. And let me just give you an example of the difference between a precision ground flat stone and a regular stone. Alrighty, so here is a piece of metal that has been ground before. It's one of my test bars. And it's been used on my mill as a spacer, as a precision spacer block, because I have 5 of these that are all the same thickness that I use to check how accurately my surface grinder was grinding across the magnetic chuck. So here's this guy. I don't know if you can hear that. And you see that no material's really being taken off at all. It'll take the burrs off these tiny scratches here. And just in case you're wondering, here's the coarse side. Still no difference. And you see that. Now there is a tiny bit of wear here where it has been scratched, and it's actually removing the material off the parts where it was scratched, off the places where it was scratched. But actual flat, nice flat hardened stock won't remove any. Now I'm going to take this very nice piece here and we're going to run it on the smooth side of this. This is a brand new stone straight from Norton. You see what it did there? Look at the difference of the scratches. Huge difference. This is all scratched up now. And so you can see there is a significant advantage to having these precision ground FlatStones. So smaller ones are really handy because you can get in a lot of places you can't with the big ones. So we're going to go over to the surface grinder and see if we can make some of our own. All right, step 1 complete. I've changed my wheel to a diamond wheel. I think this is a vitrified bond, but I'm not certain. I'd have to look it up. This is a Radiac part, and I found it on eBay at a good deal. It's an 8-inch wheel, fairly thick amount of diamond material. But the next thing I need to do is I need to true this wheel, or go and face it, and you don't use a diamond stone to do that. The best way to do that is with a motorized dressing wheel. I don't have that, but I do have another thing that's very similar. So my solution is to use a rotary dresser I found, and this one is made by Desmond, whoever that is. I found this online, and a rotary dresser is a really interesting design. A lot of them use a special braking mechanism, and they're quite expensive. This guy uses a really interesting trick, which is The wheel is coming perpendicular across this, which of course wants to rotate, but part of the force is going perpendicular to the wheel, which will remove material. And so I've never used this before, so we're just going to give this guy a shot and see how it works out. Having never dressed a wheel like this, I'm going to take it easy because I'm not sure what to expect. And of course the bottom wheel isn't dressed either, just like the top one. Okay. I found my 0 and then I went up a couple thousandths just so that I wouldn't start running into it. I just wanted to go gently. I am wearing a respirator for this. I think part of the problem is the wheel that's on there is not particularly round to begin with. Well, this really takes off material quickly. Holy cow. That's insane how quickly it takes off material. Okay. Going down another couple tenths, just trying to get this thing to self-start. Oh, it's very lightly removing material. Not enough force to cause it to continue to spin, but all right, so perhaps that was adequate. We'll give that a shot. Next, you're supposed to take a dressing stick, like one of these guys, to remove the bonding material and free up the diamonds. Making a huge mess. Definitely wearing a respirator. We'll see if that was adequate. We will try working on one of the stones next. It's my understanding that this process needs coolant the whole time. I don't know for a fact, because again, I'm out of my depth here. I'm trying to find the equivalent of a spark out. It looks like I'm touching. Okay, let's add some coolant. All right, we're at Z0, so let's see if we can go down a couple tenths, 3 tenths. All right, so it's removing material on the second stone quite a bit, the first stone just a little bit, and that was a very rough pass right there. All right, let's try that again with another 3 tenths. So I can tell the areas I've hit and the areas I haven't, because the areas I haven't hit still feel rough to my finger. The ones I have hit are nice and smooth. So I've got a low spot over here, so we got to go down some more. So it looks like I'm getting cleanup all the way across now. Alrighty, so let's see how we did. We're going to pull these guys off and see if they sound the way I'm expecting them to sound. So I can already tell you they feel completely different. I don't even need to mark the sides that I've done, because for starters, the lint-free cloth sticks to the one side, doesn't stick to the other side. So it kind of tells you. So here's the side that was not done. Here's the side that was done. That's pretty amazing. Okay, let's do the other side. Okay, ready to do side number 2. I'll pull back and show you a wider angle view. I am wearing a respirator this whole time because even though there's coolant, so that should keep the debris down from going into the air, I've got to be careful because you breathe this stuff and you're wrong about how safe it is and you're in deep doo-doo. Okay. You can hear it just barely going over the top. All right, so I've got my 0 set. So I was having success at half a thou, so let's try it. I can hear that. These should be done. These were silicon carbide, by the way. The other ones I'm going to do, these guys, which I'm going to have to do individually since they're dramatically different thicknesses, are aluminum oxide. So I'll be interested to see how different they are from each other. So if you're wondering how this side turned out. So very initially when you start, it seems like there's a little bit of free grit on them. And once you wipe that away by running them against each other, they are perfect. So this set is done. I'm very excited about that. I've half thought about doing the sides of these too, or at least one of the sides, in case you need a really small thing, but that may or may, I don't know if that'll work. So we're just gonna leave it for the 2 big sides for now. Try to 0.8 thousandths, so 8 10,000ths of an inch depth of cut. Just to try it. It's working very well. And that got me clean up all the way across. So when you rub your finger over it the first couple times, it always seems like there's a little bit of loose grit that comes off as you rub. You can hear it get flatter and flatter, like the little debris that's popping up is getting cleared. I think we're good. I think I still like the silicon carbide better, but I'm going to call it good. I know this was a short video, but we're done. You remember what they started like when we started? Now they're really nice and smooth, precision ground flat stones. Although the aluminum oxide, for whatever reason, doesn't tend to get quite as nice as the carbide does. the silicon carbide wheel, although the smooth side sounds pretty darn good, but I thought that was interesting. So if you need to take burrs and high spots off, you can hear it where it's hitting the burrs on this. But for the most part, not taking off any material at all, because it only engages the high spots. They're pretty fantastic. So I hope this was a useful video. I know, again, it was short, but if you have a surface grinder, it's not too hard to make your own precision ground flat stones. So give it a try. Thanks for watching. Hope you find it useful. Hope to see you next time.